Hello everyone, welcome to Equal To, and this is the 15th video of our number systems playlist. And in this video we are going to be solving questions from exercise 1.4. So in the past few videos we have been seeing examples from this section, and in this video we are going to be solving exercise problems based on those examples. So if you haven't watched past 2-3 videos yet, you can go and check them out. I'll give you a link. Now, let me just start with the first question here, which is classify the following numbers as rational or irrational. So, in the example section, we have discussed so many problems with the same pattern, deciding whether a number is rational or irrational, right? So, that is what you are going to do for this particular section. Okay, so what is the value of root 5? The value of root 5, as we know, is 2.236 ... It goes on forever, and we know for a fact that root 5 is an irrational number. Now, if you try to subtract this from 2, so 2 minus 2.236 and the number never ends, it keeps on going, you would end up with a number that is almost the value of equal to negative 0.236, and it keeps on going, right? So again you will be left with a number that is irrational. So this number, that is 2 minus root 5, is in fact irrational. Now these are not new concepts, we have already solved example problems with these similar format, so I hope you know that, and I hope you have seen those videos. Okay, now moving on to the next subdivision, which is 3 plus root 23, that is a single term, and minus root 23. Okay, so 3 plus root 23 minus root 23. So these root 23 and root 23, they get cancelled, right? Because one is positive and the other one is negative, and that leaves you with 3. And 3, as we know, is obviously a rational number. So this expression 3 plus root 23 minus root 23 is a rational number. Okay, moving on to the third subdivision of this question, which is 2 root 7 divided by 7 root 7. Okay, now you can write this as 2 into root 7 divided by 7 into root 7. Now you can divide both numerator and denominator by root 7, or in other words, you can just cancel root 7 from numerator and denominator, and that gives you 2 divided by 7. And 2 divided by 7 is obviously a rational number because it is of the form p by q, where q is not equal to 0 and p and q are integers, right? So this is the definition for a rational number, and it satisfies all those things, and hence this is a rational number. Okay, now moving on to the fourth subdivision of this question, it is 1 divided by root 2. Okay, now what you can do is you can try to rationalize the denominator first. Okay, so what do I mean by that? We have a particular section on that later in this exercise, but for now we are just going to write this number again, and we are going to multiply this with root 2 and root 2 in the numerator and denominator, and that gives you root 2 divided by 2. And as we know, the value of root 2 is 1.414 and so on, right? Obviously root 2 is an irrational number because it's not a perfect square and you are taking the square root of it, so it's an irrational number. So dividing an irrational number by a rational number is obviously going to give you an irrational number. Okay, so this is an irrational number. 1 divided by root 2 is irrational. Moving on to the next and the last subdivision here, that is 2 pi. Okay, so the value of pi is 3.1415 ... So pi, as we know, is an irrational number. It keeps on going and it doesn't repeat itself, right? So pi is an irrational number. So when you multiply that with 2, 3.1415, that is also going to give you a irrational number. So let me just do a small calculation here. So it's going to be 10 we are going to have a carry over 1, 2 times 1 is 2, that gives you 3, and 2 times 4 is 8, 2 times 1 is 2, dot, and you get a 6, right? So this is approximately 2 pi, right? And this digit also never ends, it keeps on going, and hence this is also irrational in nature. Okay, so 2 pi is also irrational in nature. And in this first question, we have solved 5 subdivisions, out of which only 2 are rational numbers and the remaining 3 are irrational numbers. So that is it for the first question. We are moving to the second question of this exercise, which is simplify the following expressions. Right, we are starting with the first subdivision here, which is 3 plus root 3 into 2 plus root 3. Now again, this is very similar to the example problems that we have already discussed. There is nothing new here, there is nothing innovative for you to think about. We have already solved these sort of questions. We are just going to apply that same technique here, right? Now you are going to take this 3, you are going to multiply it with this 2, and you are going to multiply it with this root 2, right? And you are going to take this root 3 and you are going to multiply it with the 2, and you are going to multiply it with root 2. As simple as that. So that is going to give you 4 terms, right? So 3 times 2 is 1 term, 3 times root 2 is another term, plus root 3 times 2 is 1 term, and root 3 times root 2 is your last term. Okay, you have 4 terms now. Let us just simplify it further. So it should be 3 times 2 is 6, and this is going to be 3 root 2, this is going to be 2 root 3, and this is going to be root 6. Now in the example we discussed also, I have mentioned that these doesn't really have to be smaller or simplified when compared to the question. What they mean by simplify is you are just going to evaluate it or just expand it. So it quite contradicts what it says, but that is what they are expecting from you, and this is going to be your answer for this question. Okay, I hope you get this. This is no rocket science, it's quite easy. Now the second one, as we have seen multiple examples of the same sort, it's quite easy. Now what you can do is, you can do the same thing you did for the previous one. You can do the similar sort of multiplication that will leave you with an answer, and there is also a simpler way. Let us come to the simpler way later. First let me just do this way. So that is going to give you 3 times 3 plus, sorry, it's going to be minus here, right? Because we have minus root 3. So minus 3 times root 3 plus 3 times root 3 minus root 3 times root 3. Okay, now this plus 3 root 3 and minus 3 root 3 are going to get cancelled, right? So this 3 times 3 gives you 9, and it is going to be subtracted by root 3 times root 3, that is 3. So the answer that you have is 6. Okay, this is one way that you could solve this problem. Another way, or a simpler way, is using a formula. So that is a plus b into a minus b is equal to a squared minus b squared. During the example problems, we have solved multiple examples with the same formula, so it's not new to you if you have watched those videos, right? Okay, now we are just going to plug these values in, and a is going to be 3, b is going to be root 3, and since it is of the form a plus b into a minus b, you can just equate it to a squared minus b squared. So that is going to be your 3 square minus root 3 squared, right? 3 squares value is 9 and root 3 squares value is 3, and that gives you value of 6. Now both these answers are same, but as you can see, this is a lot more easier, the second method. You don't have to do a lot of multiplication. Okay, so this is one thing that you can use. Now moving on to the next subdivision here, which is root 5 plus root 2 the whole square, right? We know how to find a plus b whole square, right? A plus b the whole square is equal to a squared plus b squared plus 2ab. It's the most basic formula you could learn, right? So you're just going to apply that here. A equals root 5 and b equals root 2, and it is of the form a plus b the whole square, right? So root 5 squared plus root 2 squared plus 2 times root 5 times root 2. Okay, now root 5 squared gives you 5 plus root 2 squared gives you 2 plus 2 root 5 root 2, and that can be further simplified. This 5 plus 2 is 7. This is 2 root 10. Right, so 7 plus 2 root 10 is the value of root 5 plus root 2 the whole square. Okay, now moving on to the next subdivision, we have another thing that is using the same formula that we already dealt with. Right, it's of the form a plus b into a minus b, isn't it? So when it is of that form, you can just straight away convert it into a squared minus b square and then evaluate it, and that would be very simpler. Okay, now here a equals root 5 and b equals root 2, and it is of the form a plus b into a minus b. So what you're going to do is, you're going to just evaluate a squared minus b squared. So root 5 squared minus root 2 squared. Root 5 squared is 5 and root 2 squared is 2. So 5 minus 2, that gives you 3. And that is the answer to this subdivision. Okay, I think that is all for this video. We have solved 2 questions. In the first question, we have seen if the numbers are rational or irrational by finding its value. And in the second question, they asked us to simplify, not exactly, but we used this a plus b into a minus b as well. I hope you understood these questions. If you have any doubts, please put them in the comments. I'll get back to you as soon as possible. See you in the next video. Bye for now.